Hi, lovelies. Good day. The topic of my research is early detection of Parkinson's disease, dementia, and here is my artifact. So, my objective is to identify key factors that add up to the onset of Parkinson's disease, dementia, and to compare different model on how they predict this, and also compare this model with what we currently have in the clinical evaluation tool, which is MOCA score, and also I focus on interpretability. I want my model. I want to be able to know why the model made the decision it's made. So I got my data from PPMI data and filter out what I want. And I pick my data because it's a big repo. I had to pick my data based on my research on what I think I need. So I filter out for people with PDD alone. So I get 115 people with Parkinson's disease dementia, and I went ahead and pick their visitation data so as to have a longitudinal data of these people alone. I decided not to add everybody up so I won't be having too much noise and my model will be able to focus on cognitive decline of this particular people alone. So, and this is what I have. I then after that I remove empty data by because I have so much empty space. So column that have more than 50% empty data were removed, and rows with more than 20% were also removed. Then the remaining one were just imputed with median. So, however, after that, I saved my filtered data into a new file, so I don't have to run over and over again the pre-processing process. Like that particular step, I don't want to run it over again. I put it in a new file, then reload here. Here I am looking at the key features. So what I did was to, because I have too much columns and I don't want to work with everything. So I went with ANOVA score and random forest to check for important features. I got the top important features and I work with the first 10 that were given to me. So this is me visualizing the first 10 I was given, and out of it I actually focus on this MOCA score so as to explain that this class 1 is steep. It has its peak around 30. That's because people with normal class as a higher cognitive states, just as explained in the normal clinical setting at the moment. Cognitive score greater than 26 is for the normal class, between 20 to 26 is for the MCI, and 18 and lower is for people with Parkinson's disease. Explain why the class 3 is apex at a lower value and why class 2 is apex at a medium range, why class 3 is apex around 30. That explains it. And after this, I went ahead to continue with my model building. So at first I built just logarithm regression, which has a very low accuracy. However, I use it to visualize the PDP just to check for how it's operating for me to understand it more. And after that, I went ahead to work with my 5 selected models that I want to compare. So instead of me to run it one by one, which might take too much of my time, I decided to run it in a loop and I got a comparison of the 5. So out of the 5, random forest came out being my best model, having an accuracy of 0.97, and it's better than any other model that I actually work with. Okay, so this place is still visualizing the PDP. I want it to go up so we can see the random forest coming. Okay, this is me running the loop, and here we are, random forest coming at the base. I went ahead to optimize the random forest, and actually that doesn't really help because it's just reduce it a bit, though not really obvious, but reduce the accuracy a bit. So I want to believe the model was already having an overfitting problem before, so this optimized one should be more generalizable compared to that. But however, I said I pick every visitation data of each patient with PDD, meaning I have a longitudinal data with a single person having multiple visits. So to capture this longitudinality more, I went ahead to implement my LSTM to see how it will perform. And while implementing it, I get to see my LSTM having accuracy of 0.71 at this point. And this is my graph, this is my loss graph. And again, I added attention layer so it can focus more on time visits that are more important, probably the visitation that has more impact. And that actually did not add up, so it dropped the accuracy. And that is what I have. Thank you.